Hi guys, today we're going to do section 2.7. It is in page 261. It discusses about marginal functions and rates of change. In short, what marginal function means. Marginal function. Okay, first of all, what is this? What are the functions we're discussing here? This could be cost, uh, profit or revenue. Cost, revenue or profit functions. Now here you have to understand this term. In book it's using production line. They use this to represent number of items producing. Got it? Means number of items producing, we called it production line. So in big view, this is the story. If E represent any of these economic functions, cost, revenue or profit, then the marginal economic function ME is given by E x plus 1, means economic function when it's producing x plus 1 items minus economic function when it is producing x items, right? So this E could be C cost, R revenue or profit P, right? And this marginal economic function we approximate using the derivative of the economic function given. This is the E dash, this is the derivative. Right? Now I said this E could be C, R or P. That means when this is cost, we can say marginal cost of C equal to C x plus 1 minus C x, right? We can approximate this using, this is nearly equal to the derivative of cost function. Right? So the marginal function, marginal cost is equal to, nearly equal to the derivative of the cost function. Same thing we can write to R or P, right? Okay, we can use an example to say this. Okay, I'm gonna erase this. I'm using an example from book. Given that the cost in dollars of producing X shortwave radios is Cx equal to x squared plus 80x plus 3500, write the equation. Again, this question is from the book, same chapter, section 2.7, page 262. Okay, this is the cost function, and A, find the cost of producing 100th radio, 101st radio, C dash 100. Okay, part A, asking you to find 100th radio. 100th radio, there now C of, let's see this, C100 means what? This means producing 100 radios, right? It is not 100th radio. So what question asking us to find? 100th radio. C100 means cost of producing 100 radios, right? Cost of producing 100 radios, we can find that using this equation. Not 100th radio, this is one radio, this is 100 radios, right? This is 100th radio. This is the question asking. One radio. Right, now cost of producing 100 radios we can find substituting 100 here, square plus 80 times 100 plus 3500. I get the answer from the book. It is 21,221. 21,221. Now let's find cost of producing 99 radios. C99 is what? Substitute 99 here. Again, answer to this is $279. Wait. See, no, 21,221. No, 21,000. This is 21,221. This is different. Wait. 21,500. This is from the book. I just copied it down, right? So producing 100 radios is 21,500. Producing 99 radio is 21,221. So producing 100th radio, okay, 100th radio is therefore producing 100 radios minus 99 radios. C100 minus 99. Substituting this is equal to $279. Right. To produce 100 radios it costs this much dollars. To produce 99 radios it costs this many dollars. Therefore the 100th radio costs the difference between these two, which is 279. Right. Now I write the final result. We want this at the end. So I write cost of producing 100 radio equal to $279. In part B, it's asking you to compute C 101st radio, cost of producing 101st radio. I put commas. We can do this. We can find cost of producing 101 radios, substituting 101 here, 101 for X, and C100 we already found. Getting the difference, we can find the cost of producing 101st radio is equal to right. Okay, I wrote it on the top. I'm gonna erase this. Now part B. Find C-100. C-100. To find C-100, first we have to find C-X. C means the cost function is given. We can find the derivative of the cost function C-X is equal to, differentiate this, we get 2x plus 80, then C-X C-100 equal to 2 times 100 plus 80. 200 plus 80, this is 280. Okay, now compare these three. Cost of producing 100th radio is 279. Cost of producing 101st radio is 281. When we find C-X, the derivative of cost function, when X is 100, we get 280. Look at these three. This 280 is in between these two. Therefore, we can say that we can approximate cost of producing 100th radio or 101st radio with C prime 100, right? Thus these are very close, means we can approximate 279 with 280, or we can approximate 281 as 280. So in doing that, the error is approximately 0.4%. You may calculate the error is 0.4%. This is very small. The error is very small approximating this. Therefore, we can approximate producing 100th radio of 101st radio by the derivative at the level of 100. Right? This is an example showing that we can approximate the marginal cost using the derivative of the cost function. Right? Okay. I'm gonna erase this. Okay, this thing you already know. The average cost means equal to the cost divided by number of items. Cost of producing X items divided by number of items X gives us the average cost. Let's look at 10 examples. Which one? Let's do this example. Suppose that the relationship between price of, again this question is from the book, you can find it in page 263. Relationship between price of demand for a certain type of large color television is given by the demand equation. Demand equation is given. I write the equation here. Where P is the price per unit in dollars and X is the number of sets demanded. Okay, once we get this, you know what we did, we write the demand function as P equal to something, means solve this equation for P. In doing this, we get 10P equal to negative X plus 10,000 . We want to solve this for P. This is in fact simple P, price. We use simple P for price and capital P for profit. Divide everything by 10, we get P equal to 1 divided by 10 is negative 0.1 x plus 10,000 divided by 10 is 1000. So this is our demand function. If the producer's cost is Cx equals this, okay, cost function is given. I write the cost function here. Plus 3000 determine the revenue function. Revenue function is what? Revenue is price times number of items sold. That means the demand function, this times number of items. Demand function times number of items x. So this is, substitute this p here, is equal to negative 0.1 x square plus 1000 x, negative 0.1 square 1 x square plus 1000 x. That's the revenue function. What else it's asking? Part B, determine the marginal revenue function. Marginal revenue function equal to r dash x. Revenue function, differentiate this. Revenue function is this, index n minus 1, negative 0.2 x plus 1000. Profit function, capital P of x equal to profit. How we get the profit? Revenue minus the cost. Revenue is this, cost function is this. Revenue is negative 0.1 x square plus 1000 x minus the cost is 600 x plus 3000. Negative 0.1 x square, 1000 x minus 600 x is plus 400 x minus 3000. Then what's part D? Part D, see, profit function, determine the marginal profit function. Marginal profit function we find by differentiating the profit function. So I'm gonna erase the top part of this problem. Part D, we found the profit function marginal profit is, say, MP. Marginal profit function is equal to P dash. P is here, profit function is this. To get derivative, differentiate this negative 0.2 x square, differentiate x, 0.2 x plus 400. This is the marginal profit function. E. What is the price for each color television when the marginal profit is 0? In part E, when marginal profit is equal to 0, that means P dash equal to negative 0.2x plus 400, or we can say this marginal profit equal to 0. When this is 0, x equal to 400 divided by 0.2, like 4000 divided by 2 is equal to 2000. The margin. Okay, this is part E. What is the price of color television? Okay, this is in part E, when the marginal profit is 0, when we producing 2000 items, 2000 television sets. The question is asking what is the price. To find the price, we have the price function. We can substitute this number of items in the price function. It's asking capital P 2000 negative 0.1 times 2000 square plus 400 times 2000 minus 3000. So from the book I get the answer. This is equal to 800. That means at the marginal profit, when marginal profit equal to 0, the profit is 800. Here understand the difference between marginal profit and profit. Marginal profit equal to 0 does not mean profit equal to 0. Remember the definition. Marginal profit means producing the X plus first item, right? The question is asking where the profit is equal to 0 when making which radios the profit is equal to 0. Here we found when producing 2000 radio, profit is 0. That does not mean 2000 radio cost nothing. When we produce the 2000 radio, profit is 0. When we making 2000 radios, the total profit we make is $800. Okay, F. Sketch the profit function. Sketch the profit function. Profit function is this. Look at this graph. Look at this equation. 0.1 negative 0.1 x square. X square gives us a clue. It's a parabola. It has a coefficient negative. That means it opens downwards. It opens downwards. If you do the parabola, you get an equation like when x equal to 0, y-intercept we get when x equal to 0, this is 0, this is 0, it is negative 3000. In fact, it goes like this. Right now, this is x-axis and this is y-axis. Now we interesting only the positive portion of x, because x cannot be negative, right? So I do this part, but I make it dotted line, right? That part shouldn't be there. X should be greater than 0 because x represents the number of items. Draw the tangent line when the marginal profit is 0. Marginal profit means the derivative. Derivative means the slope of the line. We discussed the slope of the line here is like this, line here, like this. Slope changes, right? What they are asking is draw the tangent line when the marginal profit is 0, means where the slope of the tangent line equal to 0. Slope of the line is 0 when it is horizontal. The horizontal line, the only horizontal line touches this curve is right here. Right? That is where the marginal profit is 0. marginal profit is 0. What does, okay, so this X is number of items, Y is the profit. This is same as profit. Marginal profit is 0 here. Now you see that this is the profit function. This is the profit function. Writing P of X. P of X profit function. When marginal profit is 0, you see that is the maximum point of the profit function, right? Therefore you can say when marginal profit is 0, profit is maximized. That's what it means. What does this profit represent? That profit represents the maximum value of maximum profit. What can you conclude about the profit at the price obtained in E? Okay. This is the price of 2000 radio. No, this is the profit. Okay, what it's asking is the what can you conclude about the profit? Okay, this means we get this when at the marginal cost. That means at marginal cost Px plus 1 equal to Px. I'm gonna erase this part to explain that. Part of P dash X equal to, okay, what is P? Let's write P first. P equal to R minus C. P dash X equal to, differentiate this equation, R dash X minus C dash X. When P dash X 0, substitute 0 here, we get 0 equal to R dash X minus C dash X. That means R dash X equal to C dash X. That means profit is, when profit is maximized, marginal revenue equal to the marginal cost, right? So when, in other words, when marginal revenue equal to marginal cost, that is a good point to stop the production. When X is at this level, it's a good time to stop the production. This is 2000. That means if you produce more radios, your profit will be less than what you make at the level of 2000, right? That's what it means. It's in fact part G. Part F is sketching the parabola. Part G is this. Okay, let's move on to another example. Example 3. It gives us a graph. I drew the graph roughly. One, two, three, four. Consider the graph of cost function given in figure 2. Does it cost more to produce 500 items? This is number of items x, right here x, but this x is in thousands. Okay, the graph is look like goes like this. Comes here. Okay. Now it's asking, does it cost more to produce 500 items? Cost to produce 500 items. First we have to figure out where this 500. This is in thousands. So this means 1000, 2000, 3000, 4000 like that. Therefore this is 1000. 500 should be right at the middle or between 0 and 1000. Now we know it's asking 500 when it said 500 this 500 when it said 500, that means marginal. This means marginal. When it is marginal, we not looking at the value, we looking at the marginal. Means what? Marginal means the derivative. Now let me tell you one more time about the derivative. derivative of this curve change from place to place. The derivative represents the slope of the tangent line. The slope of the tangent line is like this, therefore derivative is more. You see, tangent line is now horizontal, that means derivative is 0. Again it is increasing, and it keep increasing. Okay, now it's asking, does it cost more to produce 500 item, it's somewhere here, than the 1000th item? 1000th item is here. Which derivative is more? 500. This derivative is higher than this. This derivative is almost 0, isn't it? It's horizontal. The tangent line here, it has a slope. That slope is greater than this, therefore producing 500th radio cost more. This is the cost function. The reason is that. Okay, part B, does it cost more to produce 3000th item than 4000th item? 3000th item again is here. This part I didn't do well. $3,000 and $4,000. $3,000 is somewhere here. 4,000 is somewhere there. So here the slope is like this. Slope of the tangent line. Slope of the tangent line almost like this, right? Which slope is more, this or this? Slope here is more. Therefore produce 4,000 item cost more. Part C, approximately what production level is the marginal cost lowest? Okay, for that we have to look at the slope again. Slope, just move your pen or pencil along the line, it shows you the slope. Which slope is the lowest? Slope here is the lowest, it's almost 0. Look at the graph in the book. The figure is in page 265. So okay, what production level is the marginal cost? Marginal cost lowest is around here. The slope is almost 0, right? That means at the level of 1000. There we see the question just does not ask this. The cost, if you want to find the cost at that level of 1000, the cost is not 10 millions, right? So cost is 10 million. Okay, that's it for that question, right? I'm gonna erase this. Okay, now next thing is this. Okay, I give you slight small introduction about this part. This is about um, some type of physics. Don't upset if you're not good at it, but you need to know only this part. Say its distance, the distance of an object. It could move in any direction. For instance, let's think something like this. We throw an object upwards. It go up, come down, right? This distance it travels, say s, right? At different places it has different velocities. Distance increasing this direction, distance again decreasing. Notice this thing. When this object moving up, its velocity is decreasing and velocity becomes 0 here and come back. Velocity is highest here and lowest here. That means velocity decreasing in between. If, for instance, if the velocity here is 10, then it decreases 9, 8, 7, 5, 2, 0. Okay? Velocity decrease means it is decelerating or acceleration decreases, right? Now let me write this for you. The distance means this s is represented by s. This is usually a function of time. S is a function of time. Then the velocity which is v is this is the only thing you need to know about this part. Velocity we find by differentiate the distance s dash equal to, now s is ft, s dash is f dash t, right? That's the velocity we were talking here. Velocity is decreasing. Now how about the acceleration? I told you velocity decrease because it is decelerating. Decelerating means opposite of accelerating. It slows down. So I'm gonna erase this and to write the acceleration here. That acceleration, we can say when it is going up, it is going up with a deceleration. It slows down and come back. It slows down, it is decelerating, or we can say it has a negative acceleration, right? So the point is, when it is going up or down, we can use the same term acceleration. Acceleration, let's use the letter A, is the derivative of velocity v prime. V velocity is s prime, therefore velocity, the derivative of velocity is equal to s double prime, means the second derivative of s. This we also can represent as f double dash t to indicate the second derivative of s with respect to time. S is a function of time, velocity is the derivative of that function, acceleration is the second derivative of that function. Alright, so that's all we have to know to solve these questions. Let's do a question. Distance function given by negative 16t square plus 64t plus 512. Now this gives, if this gives the distance of an object from a fixed point, not necessarily going up, it could go up like this, or it could, the object could move in this direction, right? The distance here, we measure the distance in this direction. Here we measure distance from here, from a fixed point. For the convenience, we can use the starting point as the fixed point. So we measure distance from here to wherever the point we are interested in, right? Now, if the question is asking you to find the distance after 1 second, that means s1, f1, substitute it here, negative 16, 1 square plus 64 times 1 plus 512. This is a number, I get the number from the book, it is 560. In 2 seconds, S2 equal to F2 negative 16 times 2 square plus 64 times 2 plus 512. This answer I take from the book, it is 576. You may wonder where I get this equation. This is from the book. I just get this to explain the concept. To explain the concept, the average, then we can say the average velocity during the interval during the interval first and second seconds, 1 second, 2 seconds, between 1 and 2 seconds, the average velocity is given by equal to f2 minus f1 divided by 2. So substitute 576 minus 560 divided by 2 minus 1. 16 feet per second. Feet per second. Right. The average velocity. When we find the average velocity, we get the distance at the second and minus the distance at first second. We get the difference between them divided by the time interval. Time interval is from 1 to 2 is 2 minus 1. Final minus initial. This is same as y2 minus y1 divided by x2 minus x1. Right? So the slope, you remember when we get talking about the slope of straight lines, when we do that we get this answer. Now this is the average, right? Distance, velocity, acceleration, this is the average. Now this is the average velocity, the distance difference divided by time difference gives us the average velocity, average of the velocity. Now instantaneous, these we call instantaneous velocity. Velocity, instantaneous acceleration. When we say instantaneous, that is at particular place when the distance is with this we can find the velocity at any place when the time is 1.1 second, the velocity is f dash 1.1, right? We find the derivative, we substitute 1.1 if we want to find the time at 1.1 seconds. Here you cannot do it. The average means the average between two instances, you add them, divide by, you get the difference between those velocities, divide by the time interval. There you get the average, right? Notice the difference, instantaneous and average. Okay, let's do a question on this. Okay, let me give you the definition of average. Average of rate of change 2. I'm gonna erase this part. This is an example. Average rate of change is given by function fx plus h minus fx divided by h. This is the average. Then if we do it in the same way, the instantaneous, you will see the difference. Instantaneous rate of change. Instantaneous rate of change is equal to, the only difference is limit as h approaches to 0, f x plus h minus f of x divided by h, right? Average rate of change is this, instantaneous rate of change is this. This is same as f dash x, the derivative of x. Alright, now let's do an example. A ball is, this is the example 4 from page 267. A ball is thrown vertically upward with an initial velocity of 64 feet per second from the top of building. Assume the altitude of the ball given by the equation this. Determine the height of at the end of 3 seconds. Determine the velocity at the end of 3 seconds. Time it. Altitude. Okay, I'm gonna erase this. It's the same equation I used before. The ball is thrown vertically upwards and its distance is governed by this equation st negative 16 t square plus 64t let me give you the picture they're talking about. Here is a building 512 feet tall. The ball is thrown upward here. What happened is it's going up and it's coming down, right? Determine the height at the end of 3 seconds. This gives us the distance, means S is measured from the ground. I show it on here. From this level, ground level, S is measured here. Then at the, even when t is 0, it has a S value. So you see that when S0, 0 here, 0 here, it is 512. It gives us S equal to 512. Now in part A, it's asking us to determine the height at end of 3 seconds. S3 negative 16 times 3 square plus 64 times 3 plus 512. Let me get the answer from the book for the convenience. S3, they found 560 feet. Part B, determine the velocity at the end of 3 seconds. So before we find the velocity at 3 seconds, we have to find the velocity function. Distance function is given. Velocity function is equal to the derivative of distance function. Differentiate this, we get 16 times 2 is negative 32t plus 64. We 3 in 3 seconds we substitute 3 in this equation, velocity function equation. Negative 32 times 3 plus 64, it is negative 32 feet. You may wonder what this negative means. Velocity is negative, that means it reached to the top. Everything is positive in this direction. We select the direction, we select upward direction is positive direction. That means when coming down, anything in this direction is negative. Anything in upward direction is positive, anything in downward is negative, right? So this negative 32 means it's coming downward. This is the velocity, therefore it's not feet, this should be feet per second. The units of velocity is feet per second. See at what time will its velocity be 0. So velocity is given by this equation. Part C, velocity is 0 when negative 32t plus 64 equal to 0. Then t equal to 2 seconds. S stands for seconds. Part D, what is the maximum altitude reached by the ball? At the maximum, think what could happen at the maximum. Its velocity should be 0. So what we can do is we have to find the time where at which the velocity is 0. We already set the velocity function equal to 0, and we found at 2 seconds. That means it takes 2 seconds to get there. What's the question asking? What's the maximum altitude? Okay, that means it's asking the distance. So substitute t in the distance function, we get the altitude. S2 equal to -16 2 square plus 64 2 plus 512. Okay, I get the answer from the book, 566 feet. That means from here to the top, it is 576 feet. Not the top of the building, where the velocity is 0. The ball goes up here. This is the point velocity equal to 0. That is part D. What's part D? At what time will the height be 0? When height is 0 means when it go up and come back to this place. Let me erase this part here. Part A. When the height is 0, part E, Ft should equal to 0, which means this part, -16 t square plus 64t plus 512 equal to 0. We know several methods to solve this equation, quadratic equation. Everything they divide first by -16, divide by -16, we get t square minus 40 minus 32 equal to 0. Factor this out, t minus 8 t plus 4 equal to 0. Right? We set this s to 0. We divide by -16. We want to solve this. Divide by -16, then factor this out. If you cannot factor this out, sometimes depending on the question, it may be factorable, maybe not. If it is not factorable, use the quadratic solution formula to find t. Now with this we get either t equals to 8 or t equal to -4, right? T is positive value, therefore we neglect -4 therefore t equal to, we accept this answer only, t equals to 8 seconds. Because we measure time from 0. When it is here, it is time 0. Therefore we reject, or we reject this negative answer. Okay, that's E. In part F, it's asking what's the impact velocity of the ball when it hits the ground. That is what it is, its velocity the instant before it strikes. Okay. Okay. It's asking us to find the impact velocity of the ball when it hits the ground. Velocity of the ball when it is here. Okay. How long it takes the ball to go up and come down here? That is when s is 0. When s is 0, we already found t equals 8. What is the velocity at this point? That is the velocity after 8 seconds. Therefore we get the velocity function we found before, negative 32t plus 64. Negative 32t plus 64 is equal to negative 32 times 8 plus 64 equal to, let me see the answer, this is V8. V8 means velocity at 8 seconds, equal to negative 192 feet per second. Now you know what this negative 192 feet per second means. Its velocity here is downwards, so with the sign convention we selected, upwards is positive, downwards is negative. Therefore after 8 seconds it has this much of velocity downwards. In part G, sketch the graph of S. We simply want to graph this. You are well familiar with this graph, so I'm not going to discuss much about it. I'm gonna erase this part. When it comes to point to sketch this graph, it's just a parabola, quadratic equation. Therefore parabola, negative coefficient, open downwards. The only thing here we have to be careful is, here we do only for t greater than 0 means we start from time equal to 0. When you do the graph, it should be like this. This is the st versus time. Now from this graph, t should be greater than 0, therefore we take off this part, right? We don't need all this part, and its s should be positive 2 because the building, the ball goes up, come down at this place, at here s equal to 0. It cannot be negative, therefore take off this part too. Therefore your graph should be this only. So x-intercept, y-intercept, the vertex, you know how to do it, right? So that's all about it. Let's do another example. Okay, let's do this. I'm gonna erase this. I'll read the question. This is in page 269. The location S of a certain particle from its starting position is given by the equation st equals t cubed minus 3t square for t greater than 0. For what values of t is it moving in the positive direction? You remember I told you, if it say this is the object and it is, this is the thing, assume if this is a ball, if you hit the ball it keep going this way, but assume this is a car, right? You can start the car and you can move forward direction or backward direction, right? The acceleration you can change, right? This question is for such object. If equation is given, once it equation is distance or whatever the function is given, we don't have to worry about what the object is, because with the function we can say everything about it, right? If it is moving this direction, it has positive velocities, distance is positive. Whatever the quantity in this direction, we consider it as negative, right? Okay, let me write down the equation. It is given by st equals to t cubed minus 3t square, where t is greater than 0. That means we start from time 0, no negative values for time, right? For what values of t is it moving in the positive direction? We want to find what we want to find. We want to find for what values of t, it is moving in the positive direction. Positive direction. Does that mean this object is only on the right side? Does that mean that? Here. No. Why? It could have negative velocity depending on this equation. This is the distance equation. To get the velocity and acceleration, we have to differentiate this. Depending on that, it could move forward and backward as well. So it could be somewhere here when t is greater than 0, right? Not t less than 0. It's not moving always this direction. It could move this direction. It could go back and come back depending on its equation, right? To find that, let's leave it to the equation. Let's find the velocity function here. Velocity function is given by velocity, which is the derivative of the distance function, equal to differentiate this 3t square minus 6t. So it's asking when it's moving in the positive direction, we select the positive is this direction and negative is this direction. If it's moving in the positive direction, this should be greater than 0. So moving in positive direction, its velocity function should be greater than 0. That means this function 3t square minus 6t should be greater than 0. Should it have equal sign too? No. T is moving in the positive direction. That means no equal sign, only greater than 0. Now after this is after we get the condition, you may forget about the problem for a while. Solve this inequality. This is an inequality, so we can take the common factor t out. 3t minus, we can take 3 also out, minus 2 greater than 0. Okay, now what? Now here again find boundaries. You cannot say this is equal to 0, this is equal to 0. No. That is with equal sign. Boundary values. So values, we get 3t times 3t minus 2. We set it to 0 for boundary values. Here we get t equal to 0, or make this to 0, then we get t equal to positive 2 over 3. Move toward the side, divide by 3. We get this. Okay, let me write that, because some of you having trouble understanding that. Either 3t equal to 0 or 3t minus 2 equal to 0. This gives us, divide both sides by 3, t equal to 0, or t equal to 2 over 3, right? Now we get this boundary value. We have to find when this thing is greater than 0. Okay, for that I'm gonna erase this top part. We have two values, 0, 2 over 3. 2 over 3 is bigger than 0. Now let's do sign analysis. Sign analysis. This is time. When it is less than 0, we can substitute a negative value. So this is negative, say negative 1. When this is negative 1, this is negative 3 minus 2. Again, this also negative. So it is, this is positive. That means greater than 0. We don't have to check this side because the question is given t is greater than 0. So neglect, because t greater than 0 given. Let's see in between. Say let's substitute 1 here. First this is 1, this is positive. When t is 1, 3 minus 2, again that is positive. This is positive, means greater than 0. More than 2 over 3. Wait a minute, we cannot substitute 1 here. 1 is greater than 2 over 3. We want to substitute the number between 0 and 2 over 3. We can substitute half here. If you substitute half or 0.1, you can substitute 0.1 for convenience. This is 0.3, it is positive. 0.1, this is 0.3 minus 2, then that is negative. That means this is negative. Here it is less than 0. Oh, yeah, I'm sorry. In solving here, I did a mistake. In factoring, I'm sorry. When we take out 3t, it should be t minus 2. It should be t minus 2. Then 3t equals 0. T minus 2 equal to 0. T equals to positive 2. Okay. Good, I saw that. In class I can get your response, here I cannot. Alright, therefore this should be not 2 over 3, this should be 2. Let's do this sign analysis again. Less than 0, t is negative. We can substitute negative 1 here, negative, this is negative 1, negative. Okay, this part is good. Anyway, we neglect this in here. Between 0 and 1 we can substitute 1 here. 3 times 1, this is positive. T is 1, 1 minus 2, this is negative. So this is negative, less than 0 when t is greater than 2. When t is greater than 2, this is positive. So we can substitute something like 3 here. 3 times 3, 9, positive. 3 minus 2, 1, positive, equal to positive, therefore greater than 0. This part neglected. This region it is negative, this region it is positive. Therefore we can say what radius of t, it is moving in the positive direction. We can say it is moving in the positive direction. It is moving in positive direction when t greater than 2. When t is greater than 2, it is moving in the positive direction. Okay. All right. Now that's all for this question. But book do the graph of that. 3t cube minus 6t. If you take this as a function st, its graph is like this. This point is 2. 1 is somewhere here. 3, 4, like that. Okay. Now, what that means is, see, it's going. Originally, it start moving in the negative direction. It going negative direction. After that, it it's still going in the negative direction. S is still negative, and then s becomes 0. Means this is the real situation. It started from here, it goes back, come here. After that, it keep going this way, right? Now, when it start t equal to 0, when it go there and turn back at this place, this is when t equal to 2. When t equal to 2, it has a positive velocity. That's why it's coming this direction. See, distance from this point is increasing negatively, then a distance decreasing, negative distance decrease and come to 0. Now from this is the point where the velocity change its direction. Velocity change, then that negative distance decrease and it becomes to 0 place, and distance increasing positively, then distance increasing positively. This is the place where v becomes greater than 0. In this region, it is velocity is negative. That's why it's going to the negative direction. From 2 to infinity, it is positive. Therefore, you can write this as as 2 to infinity in interval notation. Alright, so that's all I have for today for this lecture 2.7. Let's see. Yeah, that's all for section 2.7. Alright, in the way I keep telling you, do those questions by yourself. Write it on a paper, not on the computer. Just listening make no sense. Once you understand, you have to be thorough to do tests or exams. Alright, so do it by yourself and stay safe. Right, take care.